Hello, and welcome to this presentation, Configuring Frequency Response Correction. In this presentation, we'll explain how to configure and use frequency response correction on Rohde&Schwarz vector signal generators and spectrum analyzers. This presentation assumes a general understanding of frequency response correction and how it's implemented. If you're unfamiliar with this topic or would like a quick refresher, you might want to watch the presentation Understanding Frequency Response Correction before beginning this presentation. As you should already know, frequency response correction can be implemented on both signal generators and spectrum analyzers. It's a software-only option that's enabled with the K544 key code. On Rohde&Schwarz signal generators, frequency response correction is available on the SMW200A and SMBV100B vector signal generators. And for spectrum analyzers, this option is supported on both the FSW and the FSV3000 family of analyzers. Let's start by looking at frequency response correction on signal generators. We'll use the SMW200A to show how frequency response correction is implemented and configured in Rohde&Schwarz vector signal generators, but the procedure, GUI, and menus are all essentially identical for both the SMW200A and the SMBV100B. On signal generators, frequency response correction is used to essentially pre-distort the transmitted signal in such a way that it counteracts the frequency response of any components or devices between the generator output and the device under test, or DUT. The frequency response of these components or devices is measured beforehand, typically using a VNA, and stored in S2P or touchstone files. Once this information has been loaded into the generator can calculate and apply the necessary modifications to the transmitted signal. In this way, the signal at the DUT input is identical to the original uncompensated signal. Note that once frequency response correction has been configured, the process is automatic for all generated signals within the frequency range of the correction data. No additional configuration or user intervention is required. Let's walk through how this is configured and enabled on the SMW200A. Because frequency response correction is done on the IQ values themselves, we start by going to the IQ modulation block and then select Frequency Response from the IQ Modulation menu. There are two tabs under Frequency Response, General and User-Defined Correction. In most cases, we want to have optimization mode set to High Quality. This is the only parameter that we need to check or configure under the General tab. All other configuration will be done using the User-Defined Correction tab. In addition to enabling and disabling correction, there are three tabs under User-Defined Correction: Common, User Data S Parameter, and Data Overview. Within the Common tab, there's a setting called Compensate Absolute Level. If we enable this function, the generator output level at the center frequency of the signal will be adjusted based on the supplied S parameter data. In this case, the amount of level correction being applied will also be displayed. S parameter data is, by far, the most common way of providing frequency response correction data, both on signal generators and on spectrum analyzers. There are, however, other data formats that can be used, for example when S2P data is not available, and these other formats are collectively referred to as additional frequency response. We won't be discussing these in this presentation, so if you're interested in learning more about them, please see the user documentation. As we just mentioned, S parameter data is normally used for frequency response correction, and this is configured under the User Data S Parameter tab. Under the User Data S Parameter tab, we can add up to 10 S parameter files, as well as rearrange or delete them. These files can also be individually enabled or disabled. Note that in order for any configuration changes to take effect, the Apply button must be pressed. The blue icon in the User Data S Parameter tab shows that frequency response correction data has been loaded and applied. On the left side of the Data Overview tab, we see the frequency range covered by each of our S parameter or frequency response files. Here, all three S parameter files contain correction data from 0 to 8 GHz. And on the right side, we see graphs of the combined magnitude and phase response for all of the enabled files. After adding frequency response correction data in the form of S parameter files and enabling Compensate Absolute Level, we can see both the amount of level correction, here 11.86 dB, as well as the magnitude and phase corrections over the bandwidth of the generated signal. Now let's take a look at frequency response correction on Rohde&Schwarz spectrum analyzers. We'll use the FSW for all of our examples, but what you learn here also applies to the FSV 3000 series analyzers as well. Recall that frequency response correction on a spectrum analyzer is designed to correct for the frequency response of devices or components between the device under test and the spectrum analyzer. As in the case of signal generators, frequency response correction data in the form of S2P files are loaded into the analyzer. The analyzer then applies these corrections to the measured signal to remove the effects of frequency response. After applying these corrections, the signal seen by the analyzer is the same as the signal at the DUT output. And, just like signal generators, spectrum analyzers automatically apply the loaded and configured corrections to all signals within the correction data range, and this occurs without any additional user intervention. Let's look at how this is implemented on the FSW. We enter the frequency response correction GUI by pressing the Setup Hard key and then choosing User Correction. Up to 15 touchstone or S2P files can be loaded and individually enabled and disabled. Information about each file, including plots of magnitude and phase, are also displayed. By default, corrections are applied to all measurement windows or channels, but they can also be enabled on a per-channel basis. In addition, the analyzer's reference levels can be adjusted automatically based on the supplied correction data. And, just as with signal generators, additional frequency response file formats are also supported. Frequency response correction typically requires characterization of devices or components in the test setup using a vector network analyzer. However, in the case of the Rohde&Schwarz HAZ24E preamplifier, characterization is performed by the factory, and the results are stored within the preamplifier itself. The FSW can automatically read the frequency response data from this attached preamplifier and then enable or disable correction for this device using a simple GUI toggle switch. After frequency response correction data has been loaded and enabled, switching correction on will automatically apply the correction data over the defined frequency range. Note that when frequency response correction is active, FR core is shown in the upper left corner of the FSW user interface. Let's summarize what we've covered. Frequency response correction is supported on Rohde&Schwarz vector signal generators and spectrum analyzers, specifically the SMW200A, the SMBV100B, and the FSW and FSV 3000 family of analyzers. S2P or touchstone files containing measured frequency response data are loaded into the instrument, and multiple files can be loaded or individually enabled/disabled for test setups containing multiple components. The magnitude and phase of each set of correction data can also be easily viewed within the graphical user interface. And after the frequency response data has been loaded and applied, correction is performed automatically on all signals within the frequency range of the supplied correction data, without any additional user intervention or configuration. This concludes our presentation, Configuring Frequency Response Correction. Thanks for watching.